Namaskar. Very warm welcome to all the viewers and learners in this live interaction of CIT and NCERT. I am Renu Bhatt with you all and you are watching us live on PM eVidya channel number 10. And dear learner, this session is for Science 10th Standard students and the topic that we are going to discuss today in this specific session is quite important. The title is Electricity Part First, and we all know electricity is a type of energy. It's very useful for us, and we have joined by our experts to throw more light on this particular topic. So, without any further delay, let's quickly meet him. You are Mr. Bergin G. You are PGT Physics from Government Boys HSS Sayalguri, Ramanathpuram District, Tamil Nadu. Very warm welcome, sir.
Thank you.
And before we start this session, let me share some certain information to all the students and viewers in case they have any query related to this particular topic or they want to know more about electricity. You can reach out to us through our various mediums. We want you to call us on our telephone number, that is 8800 440 559. Either you can drop a mail as well. Our email address is dth.class10@cit.nic.in. So, let us quickly start this session, and Bergin sir, at the very beginning of this session, we want you to explain us about the content, what we are going to discuss today in this session, sir.
Yes, in today's topic, we are dealing with current electricity in physics, class 10 physics. So, in this topic, we are going to deal with the electric current and circuit, electric potential and potential difference, Ohm's law, factors affecting resistance and the resistance of a system of resistors.
Okay. So, this was the content of this particular session. We are going to discuss today a lot of things about electricity, sir. So, here I wanted to ask you that how does the electric potential difference between 2 points in a circuit relate to the work done in moving a charge between those points, and explain how current flows through a closed circuit when there is a potential difference, sir.
Yes. To know about the current flowing through this circuit, we can start from the gravitational potential. For example, look at the screen, you can see the surface of a ground. I kept a ball there, the ball is not moving because both there is no energy to move this ball. I hold this ball and move the ball little up. So, I take this ball to a height h, so it has some potential energy because in the ground height is equal to 0, so potential energy is 0. Now, it has some potential energy. So, if I leave the ball, because of the potential energy it falls down. So, if it have potential energy, we can move the object with the help of that potential energy. In the this type of field is in the gravitational field. So, this energy is called gravitational potential energy. In the same case, instead of this earth, if I take one big positive charged ball and keep a negative charged ball just above and put it down, it will attract. If I do some work and move the negative charge to some distance, I am doing some work to move this ball. So, this work is stored as electrical energy, electrical potential energy, and because of this electrical potential energy, we can make this charged particle to move. So, this work done to move this positive charge, the work done to move this negative charge from infinity to that point is called potential. So, potential is defined as the work done move a unit positive charge from infinity to that point. If you move the charge from one point to another point, it is called potential difference. So, if there is potential difference, we can make the charge move. Now, look at this battery. We come to our real situation, this battery. One end is negative and another end is positive. Negative end has excess of negative charge and positive end has more, it is lack of negative charge, that is more, one end is more negatively electron is there, other end lack of electron. Lack of electron we can call that as a positive charge. Now, I connect a bulb with this battery through a wire, the bulb gets blown. How? Because of the potential difference, that potential difference is energy is stored because of that potential difference. This potential difference, when it is connected with a wire, that excess of a negative electron flow through the wire and the bulb gets glown. So, by comparing this gravitational potential is in the macro field, that is in the gravitational field. This electric field is in micro field. We can, even though we cannot see it, by comparing these three we can understand what is happening when a current is flowing through the conductor. So, current is flowing through a conductor only because of the potential difference exists between these 2 points, and another thing is we can make the current flow using some simple electric circuit. So, current is defined as the charge flowing per unit time. So, I can be defined as charge by time. We can go on example, a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes, find the amount of electric charge. So, we can visualize this, a battery is there, a bulb is there, a current is flowing for 10 minutes, 0.5 ampere current is passed through the bulb. So, how many charges are there? We know the formula I is equal to Q by T. From this Q is equal to IT, we can write, substitute this value I, for I it is 0.5 ampere and time is 10 minutes. We can convert into its basic unit second as 10 into 60. So, multiplying this we will get 300 coulomb. So, you just visualize these things, 300 coulomb of charge is passed through this bulb, that is 5 ampere through in terms of 5 ampere current for 10 minutes. So, that is the physical meaning of this. So, battery has potential difference. When it is converted into a closed circuit, it is a current is flowing in that circuit. In this way, the potential difference causes current. So, by knowing this current, the next important term coming in our textbook is Ohm's law. So, the same simple circuit, there is a bulb with constant resistance. I connected that bulb with a 24 volt battery, and another 6 ampere current is passed through the battery because of the potential difference. Now, I measure the resistance. Resistance means voltage by current. So, I measure the voltage and current and put it in the tabular column. The voltage is 24 volt and current is 6 ampere. So, when I divide this voltage by current, I will get 4 ohms. The same thing I repeat it, I change the voltage as 20 volt and now the current flowing is 5 ampere, again I got the same result. Again I change it, 12 ampere, 12 volt voltage is applied, 3 amperes current is passed, and when I divide 12 by 3, I will get 4. So, whatever may be the voltage, when I divide the voltage by the current flowing through the circuit, I will get a constant value. So, we can say that voltage is directly proportional to current. So, this law is the Ohm's law. So, at constant temperature, voltage is directly proportional to current. This law is Ohm's law. So, this can be, I plan to animate this using some simulation app. Because of time lag, I can't able to do that. When I change the voltage here, the current is also increases. So, as voltage increases, current is increases. That can be done in your lab also. So, if you draw the same thing in a graph, we will get a straight line. So, if it is a directly proportional, you will get a straight line. Now, I do the same experiment for another wire, I will get similar curve. So, we can understand that resistance is different for different material. So, can you find which material has greater resistance? Yes, you can find it, because if I find out the slope, this is change in voltage and below is change in current. Delta V is the change in voltage and delta I is the current, change in current. The slope, what is the slope here? Delta V by delta I. The slope will gives the resistance. So, by looking into the figure, we can easily identify that slope is greater for red wire. So, we can easily identify delta V by delta I is a constant, but the slope is low for red line. So, the wire which has red line has low resistance and the wire which has green line has high resistance. So, if anybody gives you two wires and asked to find out which has low resistance and high resistance, you can easily find out using Ohm's law. Lower slope has low resistance and higher slope has higher resistance. Also, you can identify that if resistance is high, the current flow is low. That also you can easily identify that.
Right. So, before we move further, sir, you explained Ohm's law very nicely. Here I wanted to ask you about a question from this concept, that why does the current in a conductor not increase indefinitely even if the voltage is continuously increased, sir?
Yes, Ohm's law said that when voltage is increases, current is also increases. So, your question is, as voltage increases indefinitely, what about the current? Current is also increasing indefinitely or not? So, it is not possible because every material has some fixed value of resistance that is not changing. Here look at three terms are there: voltage, current and resistance. Voltage increases, current is also increases, no issue about that, but resistance is constant for a material. So, you can't go beyond a limit, there is a limit. After that, if you increase the voltage, the current will not increase, but because of the resistance of the material. So, again if you give voltage, that voltage is converted into heat and it is dissipated as a heat energy, and even if you increase the voltage, the material will destroyed. So, we know about the resistivity, we learn about resistance. Now, let us discuss about the another important term, resistivity. I connect a small wire in between this battery. The resistance of the wire is R1. I can find out, you can find out using Ohm's law, because voltage is, battery voltage V is there, current I is, you can measure it. By dividing this, you can find out the resistance of the material. Now, I replace that resistance with a larger length. So, I increase the length and again measure the resistance. Let the resistance be R2. Now, I compare R1 and R2. Now, R2 is greater than R1. Again, I find out the another wire whose length is greater than this. I connect this. Now, the resistance of this material is R3. Now, I compare these three, R3 is greater than R2, which is greater than R1. So, from this I can understand that as length increases, resistance also increases. So, we can say that resistance is directly proportional to the length.
So, here let me tell you that, sir, we have almost 6 more minutes left for the session, sir.
Okay. So, I will complete
yes, sir, please.
With this. And also I do another experiment. Take a wire and find out the resistance, it is R1. Again increase the radius of the wire. As radius increases, the resistance decreases. Again I increases the radius, the resistance decreases. So, comparing these three, I can identify that resistance of the wire is decreasing as radius increasing. Radius increasing means what? Area increases. So, area and resistance are inversely proportional. So, I can write R is inversely proportional to A. So, by comparing these two, I can say R is directly proportional to L, that is length of the wire, and inversely proportional to A. by replacing this proportionality sign with an equal to sign, we get a constant which is called resistivity. So, the resistivity is the property of the material. From that we can it is determine the resistance of the material. So, I explain this concept with an example. If a metallic wire is stretched to double its length, what happens to its resistivity and resistance? This is a question commonly asked for the examination also. So, I take this length as L, length of the wire as L, and stretch this length to 2L. The resistance formula is rho L by A. As length doubled, the resistance also doubled. So, we can stop it here, but it is wrong. Why? There is a trick in this question. The wire is stretched. Stretched means when we stretch a wire, its length increases, at the same time its area also changing. If you stretch the wire, length increases, radius maybe decreases or increases depending upon your stretch. So, here there are two factors, L and A. Rho is constant because same material we are using. So, L and A are variable. By keeping L and A varying, we cannot fix that R. So, we have to modify this. We should not directly substitute the value of L here. So, I multiply upper side and lower side by L, so that the equation become rho L square by A into L. A into L, area of cross section into length, that is volume. Now, it will become rho L square by V. What is rho L square by V? Here now rho and V are constant because volume of that material will not be changed, even we stretch, the volume is not changing. Now, we can apply to the problem. If a metallic wire is stretched, so instead of rho it is rho only, L square. Now, here it is instead of L we can put 2L, 2L square by volume is not changing. So, by substituting this you will get rho into 4L square by V. Now, I take this 4 outside. So, 4 into rho L square by V. This rho L square by V is nothing but R. So, resistance of the doubled length wire is 4R. So, resistance increases 4 times. So, this is the thinking that we have to know. But if they ask for resistivity, resistivity will not change because resistivity of the material is constant. It is depends on material, not length and other parameters. So, if you connect,
in a brief we would like to know because we are running very short of time, sir.
Okay. If you connect resistance in series, what is the effect of the effective resistance? Now, I connect a voltmeter across R1 it is V1, across R2 it is V2, across R3 it is V3. Since it is connected in series, voltage across each resistance will be vary. The total voltage is the supplied voltage. So, we can say V1 plus V2 plus V3 equal to V. Instead of V1 we can put I into R1 because I is the current flowing through the circuit, and instead of R2 we can put IR2, and instead of R3 we can put IR3. So, we can cancel this I on both sides, we will get R1 plus R2 plus R3. So, effective resistance when more than one resistance are connected in series is R equal to R1 plus R2 plus R3, then you can add it. And if it is connected in parallel, if I current is passed through the circuit, it is divided into I1, I2 and I3. Now, here voltage remains the same and current is divided. So, we can write I1 plus I2 plus I3 is the total current. Substitute the value of I1 and I2, I3 using Ohm's law and cancel this V, we will get 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3.
Okay.
This is the resistance connected in parallel.
Parallel. Thank you so very much, Bergin sir, for this valuable information on electricity. Definitely we will be back with part second.
Yes.
And
yes,
we will get a lot of knowledge about electricity part second. Here I have to wrap up this session here only, but sir, thank you so very much, Bergin sir, for being with us. Thank you, sir.
Thank you. This is not completed. This series to be continued in the next session.
Exactly.
Okay.
So, dear learners, thank you so very much for being with us. And before I wrap up this session, let me share a very important piece of information with you all regarding our competition. It's All India Children's Educational E-Content Competition is back for the year 2024-25, and for further details and registration form, you need to visit our website, that is ciet.ncert.gov.in, or either you can scan the QR code on the screen. And do remember that 15 January 2025 is the last date for the submission of your entries. And before I wrap up, let me share our program summary with you all, and at 3:30 we will be back with our another live interaction of Urdu for 10th standard students. The topic would be अकबर इलाहाबादी की नज़्म जलवाए दरबार दिल्ली, और 4 बजे हम बात करेंगे साइबर स्वच्छता पर, आपकी गोपनीयता की सुरक्षित प्रमाणित साइबर स्वच्छता उपाय, और इस विषय पे हम बात करेंगे। आज इसका आखिरी दिन है। 5 बजे सहयोग सत्र में हम बात करेंगे नीड एंड इम्पोर्टेंस ऑफ सॉफ्ट स्किल्स इन स्टूडेंट्स डे टू डे लाइफ, एंड एट 5:30 वी विल बी बैक विद आवर अनदर इम्पॉर्टेंट एंड स्पेशल सेशन, दैट इज नीपा। और इसी के साथ मी रेणु भट्ट इज टेकिंग योर लीव, बट यू स्टे ट्यून टू PM eVidya channels for more informative programs. नमस्कार।